Working with MATLAB, it's kind of cumbersome if you just keep typing in commands into the command window, because if you make a mistake, you have a series of commands, you sort of have to start over. It's much easier to put the series of commands into a little container called script. And this way we can run the script, and if we don't like what we get, we can edit the script and rerun it. We can save the script and reuse it and maybe tinker with it and change it to customize it to our current needs. So scripts are really great and useful. So let's write a simple script where we're going to define a symbolic function, take a derivative of that symbolic function, and then substitute some numbers in. Okay, so we'll start off by clearing all the variables left over from previous work and clearing the screen. And then let's declare some symbolic variables. So let's say that we have x, y, and z, and f, and g. Okay, great. And now let's do something with them. So first, let's go ahead and define a symbolic function. So we'll say that f is equal to the sine of, say, x plus y squared. Maybe plus y. Okay, and while you're writing your script, you can actually run it before you're done just to see what you get. There's little orange lines over here. If they're red, it means there's an error. If there's an orange, it's just a warning. And so, for instance, it's telling us here, hey, if you run this script, it's actually going to spit out the answer. Is that what you really want? Do you want to clutter up your screen with all that? And sometimes you actually do. Let's go ahead and leave it like that for now. So you can run the script, and we can see it tells us that f is equal to that, and that's exactly what we meant. Good. Let's keep writing. Okay, and we're going to terminate with a semicolon now so that it won't clutter up the screen next time with the result, since we know it's already something we want. Okay, and let's say that g is going to be our symbolic expression for the partial derivative of f with respect to one of the variables. Let's make the partial derivative of f with respect to y. Okay, so the first partial with respect to y, and you already know what that's going to be just by you take the derivative of this, and then take the derivative of the inside, and then take the derivative with respect to that, and we get this expression, and that's probably what you expected to get. Good. All right, now let's see what if we could evaluate this at specific values of x and y. Since this derivative has x and y in it, the numerical value of g is going to depend on x and y. So we can substitute in specific values, and we'll put those values into a variable called h. Okay, so we're going to substitute in, and when we do this substatement, we're going to substitute into g. And here we have to put in x and y. And the way you do this in MATLAB is you list all the variables that you want to put numbers into, and then you put the list of numbers that you want to put in. So you have to put them all in the right order. And these are all enclosed in curly braces. So we want to substitute into x and y. And we want to put in some numbers. Let's say that we want to make x equal to 3. And, 3. And we want y equal to be, say, 2. Okay, and put that in. We run our script. Oh, and we see that it did substitute in the numbers, right? Because it put in, we said y was equal to 2. So we put a 2 in here, squared it to get a 4. We put a 3 in for x, so we have 4 plus 3 is 7, but didn't actually take the cosine. And the reason for this is that when you do a subs expression, it evaluates to the extent that it will give you an actual correct answer, not a decimal approximation. So for instance, if you have something like this that doesn't come out to an even number, or you have an irrational number, like the square root of 2, it will leave it as the square root of 2. Now sometimes you actually want a decimal approximation, so if you want that, you actually have to tell MATLAB, look, I just want a decimal approximation. And one way of doing that is with a double expression, which says that we want a double precision decimal approximation of h. Okay, so we hit that. Let's put that in. And so now it does an additional step of saying, oh, I'm going to put in this result out, and it gives us this result to 4 decimal places. Great, and usually that's sufficient. So that's how we can use scripts, and we can put any series of commands in a script, so they're really handy.